All right, good afternoon, everyone. Let's get started. Today, we are going to talk about course logistics first, and then I'm going to introduce what abstract data types are. And I'm going to give you a real world example, and then I'm going to summarize this lecture. All right, first, course logistics. Homework 2 was due today, and homework 3 will be out on this Thursday. All right. Any questions regarding course logistics? Okay, cool. Let's move on. I'm going to introduce what data types are, abstract data types are. First of all, let's define what abstract data types are. An abstract data type, or simply you can call it data type, defines the operations and the data supported by an object. And you could remember what we talked about last class, object-oriented programming. An abstract data type, sometimes abbreviated as ADT, is a concept similar to mathematical concepts such as functions, set, or sequences. Thus, classes, I told you that classes are templates of some typical objects. And classes, a template of an object, are the Python representation for ADTs. So this course is data structures. And what are the differences between data structures and abstract data types? A data structure is an implementation of a data type or an abstract data type. An object that provides all the operations defined by the data type with the correct behavior. There can be multiple ways to implement one data type. So let's differentiate abstract data types and data structures. The definition of ADT only mentions what operations are to be performed. So here, I'm emphasizing what. On the other hand, when it comes to but, not how these operations will be implemented. So when you're defining ADTs, you just need to describe what this abstract data type needs to do. You just need to specify the operations. And how to implement a given ADT corresponds to a data structure. And in the previous slide, I told you that data structure is an implementation of ADT. An ADT does not specify, as I told you, how data will be organized in memory and what algorithms will be used for implementing the operations. So ADT is about behaviors or the documentation of a specific object. On the other hand, data structure is how you in fact or actually implement that ADT. And abstract data type is called abstract because it gives an implementation independent view. It does not care about implementation. It only specifies the operations. And the process of providing only the essentials and hiding the details is known as abstraction. So we do not care about how these things are implemented. And this is quite similar to encapsulation in object-oriented programming. In the object-oriented programming, we don't care about how those objects are implemented. We just use them as users, all right? So that is an abstract barrier. And similarly, here we are using the term abstract because we do not care about implementation. And why do we care ADTs? When considering a problem we need to solve, it is a good idea to think about the data types that will be used to solve the problem. So in the beginning of this course, I told you that we sometimes need to design our own data structures more precisely, we need to design our own ADTs to solve our own problems. And this is what we are doing. And to define an abstract data type, you need to do some things. And the first thing you need to do is specify the possible values that that data type can have or handle. And the second thing you need to do to define an abstract data type is to define the operations that can be performed on the data type. So firstly, you need to specify possible values or the type of data that our object is going to handle, and then how we are going to operate on those data, given input data, is the next thing we need to define. Then you can solve the given problem at hand by making use of your own new data type or your new data structure. And you can just ignore its implementation or details. Or you can change the implementation of a data type later when you discover that your original implementation is too slow or has some other disadvantages. So up to this point, I discussed the definition of an abstract data type. However, that is somewhat vague, right? And I'm going to give you a real world example. Let's say we need to implement a day calculator. And what we want to do is, for a given date, what day of the week is it? We want to solve this kind of problem. And for given two dates, how many days lie between? And for a given date and a given number of days, what date is that many days before or after the given date? We want to solve these kind of problems using our day calculator. And to solve this problem, we're going to define an abstract data type called date as follows. And I told you that we need to specify, firstly, the type of data our object date is going to handle. And the type of data we are going to handle is just date, year, month, day. This is our data type we are going to handle. And the next thing we need to do is defining operations that our object date can perform. And these are the list of the operations that our object date is going to perform. Let's have a look at each one. First, date, year, month, day. This one is initiator or constructor. This one creates a new date object. And day function returns the day. Of course, we want to know the day. And month returns the month. And year returns the year. And day of week method returns the day of the week as a number. And 0 represents Monday. And 6 represents Sunday. And numDays receives another date object and returns the number of days between the two dates. And advancedBy method return a date object that is n days further, earlier if n is negative, okay? And the last thing we want to do is comparing dates using this equal sign and comparison symbols. And let's implement these data types. So this is the definition of date. Thus, we can consider it as ADT. And what we are going to do is implement that date object, and we are actually creating a new data structure. That's what we are doing, okay? And let's implement what we discussed and think about it. Here, we're going to create a class date. And of course, we need to implement this constructor first. That's the first thing we need to do. That is very easy peasy. We just need to receive year, month, and day. And we're going to assign year to year, month to month, day to day. And the reason why I am attaching underbar here is for encapsulation. Users cannot access to these class attributes directly. They need to use other functions, other methods to access to these variables or attributes. To allow that, we are going to implement some other function methods. This one return self.underbar year. Self_underbar month. So because we hided our class attributes, object attributes, or instance attributes like this, we need to give some ways for users to access or view the class attributes. Okay, these are what we do. And here, we're going to do something special. But before that, let's specify the method definition. The next thing we want to implement is day of week method. And this one returns the day of the week as a number from 0 to 6. However, implementing this method is somewhat tricky. So what we are going to use is Julian day. So let's see what Julian day is. First, so rather than using conventional day representation, we're going to use something called Julian day representation. And what is the Julian day representation? Julian day representation converts, let's say, today's March 21st. This one is what we know, the conventional day representation, right? However, let's say, if you want to know the days between these two dates, it's quite complicated to calculate days between, right? However, if you convert this to Julian day representation, it's going to be some random number. It's going to be a specific number. And let's say, this is going to be just this number plus 1. So Julian day representation is basically a continuous representation of dates. So March 31st is, let's assume that 1, 2, 3, 4, 5, 7. Then April 1st is going to be this number plus 1. Okay, so this is what Julian day representation is. And there are some functions that can convert this Julian day representation to conventional day representation. And there is another function that could convert this conventional day representation into Julian day representation. And using Julian day representation, the calculation of the days between two dates become very easy because you just need to subtract these two numbers and it will give the days between. Okay. And I'm going to just give you the definition of the method that converts conventional day to Julian day. You don't have to worry about this implementation. All right. So after you convert the day of week, just the day, month, and year, month, day into Julian day like this, you could just simply know the day of week by just calculating the remainder. So this is another reason why we are using Julian day representation when we are using computers. Okay, so calculating day of week is just calculating the remainder after dividing by 7. All right. And we also want to calculate the days between two dates when we're given another date like this. And calculating the days between these two dates become very easy when we use Julian date representation. That is simply convert another date to Julian date and then subtract that from the Julian day of self. And another special method that we want to implement is checking if the given date is a leap year. And you don't have to worry about this one as well. If this year has remainder 0 when divided by 400, or this year has remainder 0 when divided by 4, or when divided by 100, its remainder should not be 0. So this is something called Yunyan in Korean. Anyway, so this is another special method that we want to support. And the last method that we want to implement is advance by. There was a very good question from Jeo. So what is day 0 of Julian day? In fact, there is a reference point. Julian day 0 is November 24th, 4714 BC. Okay, this is Julian day 0. That is a very good question. And the last method we would like to implement is advance by. We first calculate J day, Julian day, plus these days. And what we are going to do is convert this number into conventional day again. This is very simple. However, I haven't provided the definition of this one. And when you closely look at this method, it is not bound to a specific instance of an object. And we don't need to provide self because this method does not use any of self's attribute. So we are just removing this self here, and we are putting static method here. So this is called function or method decorator. And other objects or functions can use this static method without defining a data object. All right. Okay, let's check our implementation first. So let's say D1 is date. We are going to provide 2024, 3 and 21, like this. And D2 is date 24, June 5. And what we can do is you can check day of week method. And we can also check the days between call this non-days and pass D2 like this. And day of week is 1 because today is Tuesday. Tuesday is 1, that is correct, right? And the number of days between D2 and D1 is 76, okay? Therefore, up to this point, we have seen how we define an abstract data type and implement our own data structure. And let's assume that situation has changed. And we need to support millions of date objects. Let's say we're running a social network like Facebook, and there are millions of users and millions of date objects. And we would like to reduce the storage. And how can we change our implementation so that we can save this date object in a more efficient way? Now think about it for like 1 minute and provide your ideas through chatting. All right, let's have a look at how we can change this implementation so that we can save the storage. Here, we are storing 3 attributes. Thus, we are storing 3 integers. And we can, and I told you that we could convert this conventional data representation into Julian data representation. And Julian data representation just requires 1 integer. And rather than storing these three integers, we can just store one number, Julian day. And to do that, we need to convert the given year, month, day into Julian day, like this. Then approximately, we needed to store three integers. However, now we just need to save one integer. And we're saving just 1/3 of memory space, okay? And by making this change, we need to modify other methods as well. How should we do that? First, year has to be different. What should you do? We need to convert this Julian day back to conventional year, month, day representation. And to do that, we need to use this Julian day to year, month, day method. And what we are going to do is call Julian day to year, month, year, month, day. And the first one is year. So we are going to just return the first element of this function, this method. And to return month, it's going to be the first element. And for day, we are going to return the second or third element of calling this method. And we don't have to change to day to Julian day implementation. We can just use this one. And what about day of week? Because we are storing the Julian day, we just don't need this line. However, we're just adding this self-Julian day like this. And when we are calculating the number of days, we don't have to call this method. We just get the Julian day representation like this and get the subtraction. And to check if this is a leap year, we need to get the year like this and remove this part as y, right? So these are some minor modifications. And for this, what should we do? We don't need this part, right? Because we already have Julian day, self-Julian day, and we need to add the days we want to advance. So this is a modification we make to save some storage memory. And there is some trade-off between this implementation and our previous implementation. In this implementation, we are using less memory space. However, in respect of computation, the computation has increased approximately three times. Therefore, the first implementation and second implementation have trade-off. However, we cannot say the first implementation is better or the second implementation is better. We just need to choose a proper implementation according to our application. That is the lesson from this implementation. And another thing we want to support for our data structure is when we just print D1, it prints out that main date object at this memory address. This is not what we want. What we want is a beautiful representation, such as when we print 3, it prints out 3 as expected. And when we pass string, it prints string rather than string object. So when we actually check the type of this string, it says class string. So basically this third class has the same structure or architecture as our date class. However, when we try to print out, rather than printing the memory address, it prints beautiful representation of this string. And we want to do the same thing for our date object. And to do so, in fact, we talked about it briefly in the last class. We just need to implement this third method. And this third method, let's see how we can support this functionality. We first need to get year, month, day representation. Let's run this and define this. Position our points. I guess something's wrong. I'll just show you previous implementation. So here, after implementing this third method, when we print D1, it prints the representation in a beautiful way. Okay, so when you want to support this printing functionality for your own data structure, the lesson is you need to implement this third method. All right. And the next thing we want to support is comparison. We want to compare whether D1 is larger or D2 is larger. And when we run this code, it says comparison is not supported between instances of date and date. And to implement this functionality, what we need to do is, and another thing is, we cannot compare if the given two dates are same or not. This one says just false. However, even though we make these two variables have the same date, it says false. And we want to support this functionality. How can you do that? To support that, we need to implement two other special methods. The first thing is 2_eq2_. And this RHS stands for right-hand side. Okay, and we are going to return right-hand size year is same as self year. And right-hand side month is equal to self's month. And we also need to check self's day should be the same as right-hand side day. And after we implement this equal method, then we can compare if two dates are same or not. So this should be date rather than date. Now, day. Now it says D1 and D2 have the same date. And as you can see here, there are predefined some special methods offered by Python. And those are methods have the same format. 2 underbar, proceeding 2 underbar, and following 2 underbar. And I gave you the full list of these special methods. And when you implement these special methods, then this object supports this kind of special functionality, like stir representation, comparing equality. And another thing we want to support is LE method. This one stands for less than or equal. And you might be curious, we're just implementing the right-hand side operation. So you can compare D1 and D2 in this way. However, can you also compare D2 and D1 in this way? The symbol in the right, the opposite direction. When you just implement this one-side implementation, then Python will automatically handle this case. So you don't have to worry about this case. You just need to implement the case for this one, okay? And the implementation is quite easy. First, what we are going to do is convert our date into Julian date. So we're going to use this toJulianDate method here. And we're going to get the Julian date representation on the right-hand side and just check whether this one is less or equal to this one. And another special method is just less than. This one is just less than. And the implementation is quite similar. We're just removing equal sign from this one. Okay. So up to this point, we have defined the abstract data type called date, and we implemented all the functionalities we specified. So we finished implementing the operations we specified. And to support some special functionalities, like comparing if these two objects have the same value or not, or if one of them is bigger than the other one, we came up with these special methods supported by Python, 2 underbar, proceeding and after. And are we done? What are the things we need to support more? Before we move on, are there any questions up to this point? Okay, there was a good question. Why do we need to use the static method? I'll show you how you can do this. Here, other methods require a specific instance to use these methods. So if you want to use if you want to call advanced by method, you need to have a specific instance because this method is bound to D1. However, when you want to call JDate to year month day, You don't have to have a specific instance. You can just call date object like this. And still, you can call this method. However, when you try to run the same method, advanced by, with this template, then it's going to occur an error. It says it should be bound to some specific instance. However, it is not bound to an instance like this. The first thing it should receive is the date object like this. So basically, to summarize, the static method doesn't require any objects to run. However, other objects require a specific instance of that class to run because it modulate some attributes, class instance attributes in some way. However, this one does not modify or modulate any instance attributes. So that is why we are using static method here. Does this answer your question? Okay, that was a good question. Any other questions? Another thing we need to support here is up to this point, we just assume that users are passing the correct arguments. However, let's assume that what if users try to pass some incorrect values like D3, date, 2023, and March 40th. This is not valid date, all right? We cannot pass 32 or 50. However, in our implementation, it works. However, it is not what we want. And in some way, we need to warn users that you are passing some wrong number to initiate a date. And what we can do is, we can put some, before we initiate our object, what we can do is, we're going to check the validity of the arguments. So Jeff suggests that the JDate function has some error protection for this case. Not really. So we need to check. So what we are going to do is check the validity of the arguments. And as Jeff says, we're going to do some error protection. And how can you do that? That is quite simple. We're going to convert the given year, month, day into JDay. And we're going to convert this JDay back to year, month, day representation. And if these numbers do not equal, then it is not a valid representation of a date. Then here, you entered a wrong date. However, rather than doing this, what we can do is raise an error. The value has incorrect value. So here, I am introducing a new keyword, raise. Okay, so you can raise an error like this. Let's check what this is doing. So when we try to initiate self-to-date, JDate. This one should be modified. Okay, I'm going to give you the working code after class. But anyway, after we implement this part, this date object will raise an error. All right. So that one is similar to like this. This one says value error. It receives some wrong number, and it is not a string representation of a number. So this one will raise similar error as this one. And it says invalid error for int with base 10. So 3t is not a valid number. So you can pass some message, error message like this. You can form your error message on your own. All right. So this is what we need to do to implement our date or data structure. And let's have a look at more exceptions. Here, I'm using a new term, exceptions. Exceptions are not intended inputs from users or not intended behaviors incurred by users. And we need to handle those exceptions. Otherwise, our computers are going to just terminate. And we do not want that. And let's have a look at some examples. Let's say A is 3. And when we try to divide A by 0, it's going to occur on 0 division error. And from this error message, we know that, oh, we should not divide an integer by 0. And this one is just what I showed you. When you try to convert this string into integer, it says value error. You just pass invalid error for int initiator, and this one is not a valid number. And another type of error we could see is when we try to make this list very long, like this. It says overflow error. It cannot fit int into index size integer. So this is too long. And what Python is doing right now is it's protecting the computer from invalid behaviors or invalid arguments passed by users. And we need to do the same thing for our data structure. If users try to enter some wrong numbers or try to use date in a wrong way, we need to protect or handle those exceptions. And that's what we're going to do. Okay. Let's have a look at some example. I'm introducing a new function called input. This receives an input from user, integer. And when we try to handle some exceptions, what we usually do is use this try and except blocks. So what it does is, Try to run this part. I'll implement this first and then show you what's the difference. So what it does is, this is what we actually want to do. Receive some input from user and then convert this string into integer and then print out this number. This is what we want to do. However, users might not enter the correct integer representation. In that case, we need to handle that error or exception. And we are going to handle that exception in this except block. So we are using try block and except block. So this one is what we want to do, what we want to offer users. And if users do not do what we intended, then we need to raise some errors. And errors can be raised by this integer function, or we can raise errors by ourselves. I'm going to show you how we can do that shortly. And if error occurs, what we are going to do is specify in this except block. Let's run this and check what this can do. Here, we're receiving some numbers like this. And if this number is correctly converted to string, it prints out you said 3. However, when we want s, then it means it is not correctly converted to integer because s is not a number. And here, because this one fails to convert the given string into integer, rather than going to the next line, it goes to the except block. And this except block says, oh, the string you are given is not a number. So this is basically how we can handle some exceptions. Okay. And one thing you need to understand here is when an error occurs inside this try block, it just stops right there. As you can see here, when we passed s, which is not an integer, it goes into this integer function and it occurs an error. And it does not go to the next expression or next line, printing line. It stops right here and then goes to except block. And the except block will handle the error. And I'm going to give you another example. Let's say we have a function called f. So f starts here. And we're going to call gn. And we're going to implement gn here. And what gn is going to do is divide 100 by n. And end up g like this. And I'm going to give you the definition of main function. So what it does is receive a number and pass this number into f. And here, we are going to try block. And it says beginning of try block. and it converts the given string into n and pass this number to fn. And fn starts receiving that number. So here, starting of f10, printed here. And this fn goes to gn, and it says starting of g10. Then it calculates m, then it prints out the result. And the result is printed out here. The result is 10. And f is ended, g is ended, and then f is ended, and then try is ended. And if you just enter, it stops. So if I enter just blank, then it will just terminate. And let's see what happens if I input some wrong string. Then it says beginning of try block. So it goes to this try block. However, it failed to convert this s into a number because this s is not a number. And rather than going to f, so the starting of f is not printed here, as you can see here, and it directly goes to value error. Because value error occurred, it says please enter a number. And here you can see that there are multiple except blocks. And because there can be different types of errors caused by users, and you need to handle those errors separately, you can have multiple except blocks. Okay, let's input some 0. And it says, it first goes to the beginning of the try block, and then it starts to run the f. And it calls g function. And it says starting of g here. However, because we cannot divide 100 by 0, it does not go to the next line. The result is blah, blah. However, it directly stops there and then goes to this except zero division on zero division error. And it prints out, I cannot handle this value. This is the flow. And the takeaway is when an error occurs, it does not proceed. However, it stops right there and goes to the except block. And it tries to find the correct error message. Okay, so that is what I want to emphasize. Are there any questions up to this point? There was a question, rather than having this except block, can you just use if and else blocks like this? Yeah, that is also okay. However, when you just run this if and else blocks, you cannot differentiate between errors and some operations. So these are to make error handling more explicit. However, it is okay to use if and else. So the reason why we are using try and except blocks is to let other programmers to know that, oh, this is for handling some errors from users. Okay? And let's see another example. I told you that we can actually raise errors by ourselves. Let's say we do not want to handle negative numbers like this. In this case, I told you that we can raise some errors. Cannot handle negatives. And when we run this and pass -10, it's going to say, please enter a number, right? And we cannot access to this, cannot handle negatives. And one of the ways we can access to this error message is slightly modify this part. We're going to modify this one is as E. We're going to receive this value error as E. And we're going to say, please enter a number and percent string and percent E. Then rather than just saying, please enter a number, we can access the error message like this. Please enter a number. Can I handle negatives? Like this. Okay. So when you enter or raise your own error, and if you want to access to this error message, then you need to receive it as a special error, like as E. And then you can handle this E as you want. And the last thing I would like to mention here is rather than just raising these predefined errors, so value error or zero division error are predefined errors, you can also define your own errors. Class my error. This is my error. And you need to inherit the mother function exception. And you're going to init this one. And you need to call the mother's init initiator. And you just need to pass some default error message, custom error message like this. And you can check this implementation like this. We're going to raise an error. Like this. And as you can see here, this one says, try statement must have at least one except or finally clause. Meaning that when you try to enclose your some part of code with try block, you need to have at least one except block because you need to handle some errors. Except my error as E and print error occurred. You can just pass E like this. And let's run this test code. And it's going to say, I'll raise an error and whatever value I pass will raise an error like this. Error occurred, custom error message like this. So the takeaway is you can raise predefined errors or you can define your own errors like this. And so when we try to implement our own data structure, what we need to do is first define the data types we want to handle. And then we're going to define and define the operations that our date object needs to support. And the last thing we needed to do was handling some of these exceptions because users would not pass the correct or valid arguments all the times. They can make mistakes. So we need to handle those mistakes with try and except blocks. All right. So up to this point, are there any questions regarding try and except? Cool, let's move on. So in summary, we introduced abstract data types today. It is about what, and we compare abstract data types and data structures. And data structures are about how we implement. And we discussed one real world example, and we covered how we can implement exceptions in Python. And this is the end of today's class. If you have any questions, you can stay here. Otherwise, you can leave now. Thank you for your participation.